Welcome back to Knowledge Hub. Why is there no up and down in space? There is an up and down in space. Down is simply the direction gravity is pulling you, and up is just the opposite direction. Since there is gravity everywhere in space, there is also an up and down everywhere in space. Gravity is a centrally attractive force, so going down means falling or being pulled towards the center of the nearest massive object. If you are in space and the Earth is the nearest astronomical object, you fall towards Earth. Down is therefore towards the Earth's center and up is away from the Earth's center when close to the Earth. Down is not towards the Earth's south pole and up is not towards the Earth's north pole. This mistaken notion comes from the way we traditionally hold flat maps. The Nile River would never flow north if north were really up. Unfortunately, in an effort to explain why north is not up and south is not down, many people conclude there is no up or down in space, which is clearly wrong. If Earth is the closest large body, down is always towards the center of the Earth and up is always away from the center of the Earth. Nothing magical happens if you leave Earth's surface and board the International Space Station. Down is still in the same direction. But if you look at the astronauts on the International Space Station, they seem to be floating around with no sense of up or down. This interesting behavior is not due to a lack of gravity, but is due to the fact that they are in free fall. When falling freely, our human senses cannot detect which way is down. But there still is a down, evidenced by the fact that you are accelerating in the down direction while falling. If you jumped into an empty elevator shaft from the 50th floor and closed your eyes as you fell, you would not be able to tell which way is up, ignoring air resistance. The gravity did not magically disappear in the elevator shaft just because you closed your eyes and jumped. The down direction is still very real and is evident from the fact that you are falling in that direction, even if you can't feel which way is down. It is the same with astronauts in orbit. The round path of their orbit is a direct indication that they are falling and that they are experiencing a down, which is towards the focus of their orbit, even if they can't feel it while in a state of free fall. What would happen if you got far enough away from the Earth that its gravity were no longer significant? Then you would simply fall towards whatever body has the strongest gravity. Near the Moon, down is towards the Moon. Near Saturn, down is towards Saturn. If you are not particularly close to any planet but are still in the solar system, down is towards the Sun, the very center, actually, because that is the direction gravity is pulling you. If you start at rest relative to the Sun and are far away from the planets, you will fall towards the Sun. If you go out of our solar system and do not enter another solar system, down is towards the center of our galaxy. If you get out of our galaxy and don't enter another galaxy, down is towards the center of our cluster of galaxies. If you get far enough away from our cluster of galaxies, down just becomes towards the next closest cluster. All matter in space is constantly falling down. Space is so big that this falling down motion is so slow that on an astronomical scale that we don't notice it much. But it is definitely there. Because the falling of spaceships, moons, and planets looks much slower on astronomical scales than you falling off your roof, scientists don't use the word falling much. Instead they talk about orbits, trajectories, and paths. Whenever they use such terms, they really just mean things in space falling down. Thanks for watching.